Screen is visible to all of you?
Yes, sir.
Okay. So, today we will discuss again about unit number 2, right? The points which are not understood by you. So, our next point of discussion is VHDL code for the up down counter, right? In last sessions, we have discussed about the flip flops, all types of flip flops. Again, we have discussed once again. Then, shift register, right? Serial in parallel out SIPO shift register. Okay, and some of the basic questions that you stuck at about the VHDL programming. So that part we have covered in last lecture. So in this session, we will discuss these two programs. Okay, these are again very important program as far as your exam point of view is concerned. So up down counter, then flip flop, ALU, then shift registers, multiplexer, decoder. These are the what we can say very high probability questions that may come in your exam. Okay, so we will start with this. Okay, so this is the functional block diagram of up down counter. So first tell me whether up down counter is a combinational logic or sequential logic. Up down counter is a combinational logic or sequential logic.
Combinational logic.
Combinational logic. Okay. Any other opinion?
Combinational, sir.
Combinational logic. Okay. But if I use or while designing this counter, if I use some memory or some flip flops, then it becomes a sequential logic. So actually, it can be a combinational logic if specifically you are using for a counter purpose, or if I will add some additional features such as you can store the last counts, or you can store the say what we can say some predefined counts, right? So if memory is involved, then immediately it becomes the sequential logic. Okay, unless and until memory is not involved, it will be combinational logic design. Okay, so this is the basic block diagram of this up down counter. Okay, so what inputs that you may require? First, you require a clock. Okay, you must require a clock pulse because we need for the measurement purpose. Okay, how we are measuring the actually the what we can say the seconds or times? So that is by what we can say enabling the clock. Okay, so the your clock pulse are actually nothing but the count that we are using. Okay, then mode. Okay, mode means what? Whether you want that counter to be behave as a up counter or down counter. What is up counter? It increments, and down counter means it decrements. Up counter means 0 to 100 it will count. Down counter means 100 to 0, reverse order. 100, 99, 98, 97, 96, 95, 94 accordingly. Okay, and once you have completed the first count operation, again you want that same counter to be reused. So first and very basic thing that you need is you have to reset that, right? So a reset button is also important. Okay, so mode is required, then clock is required, and reset counter is also reset pin is also required, and obviously whatever the count that it is what we can say counted, you have to check that. So for that purpose you require output also, right? So it is 3 down to 0, that means a 4-bit value it can show, and up to 4-bit value it can count. Okay, so this is a very simple and basic block diagram of up down counter. Now we will discuss about its VHDL code. Okay, now again this is mandatory part. Okay, now we have studied almost like 15 to 20 programs of different logic. So everywhere library should be there, everywhere entity part is there. So again, need not to explain this part. Actually you are all of aware of this part. Okay, you use IEEE, this is the library, this is the package, and this is the items in that package. Okay, similarly this is the library, this is the package, this is the items in that package. Library name is IEEE. In that library, this is the package standard logic unsigned, this is the name of package, and in that package which items you are using, so almost all items we are using, so that's why we are writing dot all. Okay, so always remember library dot package items, this is the standard format, right, to define the library section. Okay, and at the start you have to define the library. So here we have defined library IEEE. Okay, that means this library we are going to use IEEE library. In that IEEE library, which packages we are using? So this is the first package, standard logic 1164, then standard logic arith, this is the second package, and standard logic underscore unsigned. So these three packages we are using, and within that package which items we are using, so all items. Okay, all items. So library, package, items. So always remember this is the standard format. This is about the library part. This is the entity part. Okay, so num, input, then clock, load, reset, then input this standard logic, as well as sorry, this num is actually input, it is a vector 3 down to 0, then clock pulse obviously again input, then load is also again input, then reset is also input, dir that is direction, this is also input, and output is nothing but the output vector 3 down to 0. So this is the entity part. Okay, now we will discuss about the architecture. As we are using here process statement, if else statement, if then statement, right? So but obvious it is a behavioral style of modeling. Okay, so again I will repeat how you are going to identify the different styles of modeling that we are using. Whenever you find process statement, if else statement, else if statement, if then statement, so it normally it is a behavioral style of modeling, right? Then next is whenever you find when statement, when then statement. Okay, then some boolean equations you find. Okay, then case statement, select statement. In behavioral modeling also we can use the case and select, but whenever you find when else, when then statement, okay, case, select, then it is a or some boolean equations, then it is a data flow modeling. And whenever you are finding the split in design, that means we are actually configuring the entire design by the small units. Okay, for example, as we have discussed while discussing the structural style of modeling, right, we have used the two half adder along with OR gate, that entire code forms the full adder. Okay, that means whenever you find the split into a design, that is nothing but the structural style of modeling. Okay, so by using the or by looking at the code, which statements it is being used, so you can easily decide which style of modeling it is. And always remember, in behavioral modeling, process statement most prominently used. Okay, but in case of structural modeling, process statement never used. Okay, so that is the what we can say the rule that you should understand. Okay, in structural we hardly use, or we are never use process statement in case of structural style of modeling. Okay, so by looking to your program, you can easily understand which style of modeling actually you should use or it is being used. Okay, so this is the architecture part. Okay, then again we have this temp. We have defined this signal, right? Signal temp standard logic vector 0 to 3. Okay, so again this is the signal that we have defined. Now as we have defined this as a signal, can we use this signal outside the process? Can we use this signal outside the process? Yes or no? सिग्नल आपण प्रोसेसच्या बाहेर वापरू शकतो का?
Yes.
Okay. Now, if instead of this signal, after this process, if I have declared the variable, right? That means this instead of this signal, okay, after this process, if I have declared this variable, now answer me, can I able to use that variable outside the process?
No.
Okay, and answer is correct. Okay, but again, if I use or I define that variable before the process statement, okay, is this a valid move? व्हेरिएबल हे मी प्रोसेसच्या आधी डिफाइन केलं तर चालतं का? Answer is no. Okay, signal you have to define before the process and it can be used outside the process. हे लक्षात ठेवा. म्हणजे सिग्नल हा प्रोसेसच्या अगोदर डिफाइन करायचा असतो आणि तो प्रोसेसच्या बाहेर सुद्धा यूज होतो. दिस इज अबाउट सिग्नल. व्हेरिएबल हे कायम प्रोसेस नंतर डिफाइन करायचं आणि ते प्रोसेसच्या बाहेर यूज करायचं नाही. हे थंब रूल आहेत प्रोग्रामिंगचे, VIDL प्रोग्रामिंगचे, and you have to remember this. Okay, signal you have to define before the process and it can pass outside the process also. This is about signal. About variable you should define after the process. म्हणजे हे प्रोसेस लिहिल्यानंतरच तुम्ही व्हेरिएबल डिफाइन करायचं. बरोबर आहे. इथं आपण हे प्रोसेसच्या अगोदर सिग्नल डिफाइन केला. ओके, सिग्नल कायम प्रोसेसच्या अगोदरच डिफाइन करायचं हे लक्षात ठेवा. आणि व्हेरिएबल हे प्रोसेसच्या नंतर डिफाइन करायचं आणि ते प्रोसेसच्या बाहेर यूज करायचं नाही. सिग्नल हा प्रोसेसच्या अगोदर डिफाइन करायचा आणि तो तुम्ही प्रोसेसच्या बाहेर यूज करू शकता. सो दिस इज द what we can say the thumb rules of VIDL programming and that you have to remember. Okay, then we have defined this signal temp, process, clock and reset. Begin. After process, again once again begin should be there. Now if we are using the if else if condition, if reset is equal to 1, that means we have reset that counter, then this temp variable should get 4 times 0 value. बरोबर आहे, कारण तुम्ही रिसेट केलाय काउंटर. means it should flush out all the previous data and it should be initiate that what we can say the variable or the output as 0 0 0 0, right? Because reset means the initiating. बरोबर आहे. रिसेट करतो म्हणजे काय करतो आपण? वी आर फ्लशिंग आउट द ऑल प्रिव्हियस डेटा अँड वी आर बॅक टू द ओरिजिनल कंडिशन or starting condition. That is the reset condition. So starting condition is always 0 0 0 0. So when reset is present, then temp will get this 0 value. Okay. Else if means what? If reset is not 0. Okay. If reset is not 0, then clock tick event and clock is equal to 1. Okay. If reset is 1, make it 0. Else if means if reset is not equal to 1, means reset is 0, then what will happen? Then it will check for clock tick event and clock is equal to 1 again. Then if load is equal to 1, that means if we have, whether we have loading something or that count that we want to count actually. Okay, so we have entering that counter value, that is the load. If load is equal to 1, then temp will get value num. Okay, if temp will get value num, that means whatever the count value that you want to enter, so it will get allotted to the temp value. Else if load is equal to 0 and direction is equal to 0, then temp will get temp plus 1. Okay, else if load is equal to 0 and direction is equal to 1, that means in first case we are actually it as a incrementing counter, that means up counter. And if direction is 1, then it will act as a down counter, that means it will reverse count, or it will count in a reverse manner. Okay, then temp will get temp minus 1. Okay, and if end process, and finally output will get that signal temp. Okay, and again as you can see here, after ending the process we are passing that signal value. After ending the process we are passing that temp signal value to the output. Why it is allowed? Because we have defined it as a signal. बरोबर आहे, सिग्नल आपण डिफाइन केल्यामुळे ते आपण प्रोसेसच्या बाहेर सुद्धा त्याची व्हॅल्यू पास करू शकतो. ओके, सो दिस इज अ व्हेरी सिंपल प्रोग्राम ऑफ दिस अप डाउन काउंटर. ऑल ऑफ यू क्लियर विथ दिस? समजलंय का?
Yes, sir.
Yes, sir.
ओके, फाइन. Anything else that you want to repeat in this unit number 2? I will discuss this program also of ALU, arithmetic and logical unit. But besides this, anything else you want to repeat, you can tell me. All of you understood this up down counter program?
Yes, sir.
Okay, fine. Then we will do one thing. We will stop here. In next lecture, once again I will explain this arithmetic and logical unit program, and after that we will start with the unit number 3, that is Verilog codes for the sequential and combinational logic design. Okay, so today you go through that unit, and whatever the points that you are facing the problem, or that you are not understood, you simply note it down. In next lecture we will discuss that. Okay, so in next lecture first we will discuss this program, and then we will start with the unit number 3. Okay, so you today only you just go through that unit, and you just note down the points. We will discuss that part. So we will stop here.
Sir, very